Imagine you invested in a company. Every day the price changes. Some days you gain money, some days you lose it. Now imagine you had a time machine. You could choose exactly one period to stay invested. Which days would make you the maximum profit? Surprisingly, computer scientists solved these problems decades ago, and the algorithm they invented is pure genius. This array represents our daily profit and loss. Positive numbers mean profit, negative numbers mean loss. Our task is simple. Find the continuous portion of this array whose sum is the largest. First, let's see about the brute force approach. What could be the brute force one? Select every single subarray, find the maximum one and just return it. This is the brute force one. So what could be the time complexity for this one? Which is big O of n square, because we will be traversing the entire array again and again to find the subarrays, which could take at most n square times complexity, right? So this is the brute force one. So this is suitable when we have a very small number of things. But what when we have a large array? Say it has some thousands of numbers, billions, it can't work. To solve this problem, Kadane noticed something brilliant. Imagine you are carrying a backpack. Every loss adds another loss. At some point, carrying the past hurts your future. So, what you will do? You will just throw them away. If our running sum becomes negative, why carry it forward? Just drop them. Now comes the real algorithm. To solve this, we just need only two variables. Just which one is going to return the maximum sum, not zero, array of zero. Because sometimes you might be end up in loss, right? So it's always better to initialize it to zero. And your current sum, which is also going to be array of zero. I'm going to run a for loop in I is equal to 1, I less than array dot length and I plus plus. Why am I running it from 1? Because I already initialized 0 to be my maximum sum. So I'm just going to check current sum is equal to math dot max of. I'm just checking if my past is hurting me or not. So if the past is hurting me, the current value which I am at, see, if minus 2 is going to hurt me. So when I am present at 1, 1 is greater than what? Current plus array of, sorry, it's not current, it's current sum. So from this, you need to understand very clearly. Current sum means at first it's going to have minus 2. Minus 2 plus 1 is minus 1, which is hurting you. If you are at 1, you could get a maximum profit of 1. Why do you need to get minus 1? So that's what happening here. If this is the condition, you are continuing the array. That's subarray. If this is the condition, you are breaking it and starting a new subarray. So here it would be like this. You are asking whether I need to continue it like this or I need to break it here and start with here. So next, maximum sum. Max sum is equal to math dot max of what? Current sum comma max sum. Because you need to have a check, right? Always max sum is going to be the maximum thing that could be possible. So return max sum. Simple. That's it. Let's try running this. System.out.println. Oops, that would be a problem. Maximum sum Kadane. That's good. Maximum sum Kadane and passing this array. 6. It works perfectly well. So hopefully it's clear. You are just having one idea. That is, if the past is hurting your future, just leave it at the back. Or else, if it is going to support you, then just carry it away. So even simply if we could say, if today's journey is better, we save it for the future. That's it. Now let's see about the complexity. In the brute force one, I said O of n square. Because there you will be having something like this. For inside another for. Since you will take every single subarray, right? So you need to take this, then go from here. Choose this subarrays, then this, which would lead to something like big O of n square. Now, how many loops are you running? Oops. How many loops are you running over there in this Kadane's algorithm? Only one loop. How many traversals you make? N traversals. So the complexity is going to be big O of n. And the beauty of this Kadane's algorithm is knowing exactly when to let go something. So yeah, it's simple. Hopefully it's clear. Thank you for watching.